Why is a box plot useful for representing certain types of data? Think about this question during the lesson. Helen wants to display the lengths of 15 fish she caught this year. How can she use the data to make a box plot? A box plot is a diagram that shows the distribution of data values using the median, quartiles, minimum value, and maximum value on a number line. Why do you think a box plot will help you see the distribution of the data more clearly than the table? Since the data will be shown on the plot above a number line, you will be able to see how the data are distributed. The table does not visually show this. Find the median, minimum, and maximum values of the data. What is the median?
Select your answer.
The median is 13. Find the median for each half. Quartiles are values that divide a data set into 4 equal parts. Draw the box plot. Show a number line with an appropriate scale. A box between the first and third quartiles, and a vertical segment that shows the median. Draw segments that extend from the box to the minimum and to the maximum values. Why do you suppose a box plot is also referred to as a box and whisker plot? What does the box represent? The lines from the box to the minimum and maximum values look like whiskers. The box represents the middle 50% of the data values. Now you know how you can draw a box plot. The lengths in inches of 11 fish that Helen caught last year are listed below: 7, 8, 12, 12, 12, 13, 14, 15, 16, 17, 22. What are the first quartile, median, and third quartile?
Thankfully for us, they already listed the data from least to greatest. So first thing first, we need to find the median. The median is the middle number. So we know there's 11 fish. So that's an odd number. So we know there's going to be 1 in the middle. So I'm just going to draw a line connecting my pairs so I know which one is definitively in the middle of my data. So we have these. I think I did something twice. Let me do that over. Okay, so we have 11 fish. I got 7 and 22, 8 and 17, 12 and 16, 12 and 15, 12 and 14, and so 13 is the one that does not have a partner. So our median is 13. That's our median. I'm just going to underline it in the same color. So that is our median. Now we need to find the first quartile. And the first quartile is going to be the median of the lower half of the data. So here's the lower half of the data, right? That's on the left side of the median. And for this, we have 1, 2, 3, 4, 5 numbers, right? And so that's still an odd set of numbers. So we can do the same thing by connecting the numbers. So we got 12 and 8. And then this other 12 is left in the middle. So our first quartile is, I'm just going to underline that, our first quartile is 12. Now we need to find our third quartile. So our third quartile is going to be the greater half of the data. So that would be the numbers to the right of the median. So again, there's 5 numbers to the right, so there's going to be one middle number. So we're going to just pair them up again. 14, 22, 15, and 17, and 16 is going to be that third quartile. So now we've found our median, first quartile, and third quartile. That's all they asked us to do.
The Earth Club collected enough donations online to build compost bins. How can the club record the donation information in a box plot? A box plot uses 5 boundary points to show how the items in a data set are distributed. To make a box plot for the data, the first step is to find the minimum, median, and maximum values, as well as the first and third quartiles. Begin by listing the $12 values in order from least to greatest. Now that the values are in order, it's easy to see that the minimum value is 10 and the maximum value is 60. How can you find the median value for this data set? There are 12 values, so the median is the average of the 2 middle numbers, which are 25 and 35. The median is 30. How do you find the first and third quartiles for the data? There are 6 values in each half. The quartiles are the averages of the 2 middle numbers in each half. The first quartile is the average of 15 and 25, or 20. The third quartile is the average of 45 and 50, which is 47 and 5/10. The second quartile is the same as the median. Now we're ready to draw the box plot. The donation values are from $10, which is the minimum, to $60, which is the maximum, and they increase in $5 increments. So a good scale for the number line is $5 to $65, numbered by 5s. On the number line, identify the minimum, median, maximum, and the 2 quartiles. Draw the box between the first quartile and third quartiles, with the median line in the middle. Then extend the box to show the minimum and the maximum. Here is the box plot for the 12 donation values.
The interquartile range, or IQR, is a measure of spread for the middle half of a data set. It is the width of the box in a box plot. The box plot shows the weights, in pounds, of bags of donated clothing. What information do you know from the IQR?
So the first quartile is 12. We drag it to see if it's true or false. So the first quartile is 12. Is that true? I believe it is, because our median is this line here, and the first quartile is the median of the lower half, and 12 is less than that median of about, I guess it looks like to be 17. So I'm going to say true. So let's see. And then it says the first quartile is 8. So we have 8 here, and there's our first quartile. Well, we just said our first quartile was 12. So if we think that is true, then this has to be false. The third quartile is 20. we look at our box plot, and then we have 20 here, and then we have our line. And these lines are representative of the minimum and maximum numbers, those whiskers, right? So then the third quartile can't be 20, so I'm going to say false. Then I'm going to look at the next one. The third quartile is 18. So we look here at 18. 18 is the other end of the box, and that is our third quartile because that's the median of the upper half of the data, which is that third quartile. And so we're going to put true. Then it says the median of the data set is 14. That line here is our median. Is that 14? No, it is not. So we're going to say that is false. Now it says the median is 17. We look back and we see that line is at 17. So that is going to be true. The next sentence says the weights of the middle half of the bags of clothing are within 6 pounds. So you take the maximum and minimum and subtract them. The weights of the middle half. I'm going to say that's a false, because that's not close to that. Oh, I'm not right. Let me go back and look. Apparently I misinterpreted that data. So I was mistaken and I subtracted the maximum and minimum, which is incorrect. You are to, because it's asking about the weight of the middle half. So we have to take the medians, the quartiles, the first and third, and subtract those numbers. So 18 and 12. And if you subtract those two, you do get 6 pounds, or 6 as the difference. So that is indeed true. So the weights of the middle half of the bags of clothing are within 12. Because we said it is 6, that has to be false. So we're going to put that in our false column. And there are all the true and all of the false statements about that data. So the median of the data set is 17, the first quartile is 12, and the third quartile is 18. 18 minus 12 is equal to 6. The weights of the middle half of the bags of clothing are within those 6 pounds. The ages of 12 volunteers participating in a beach cleanup are shown, and there's our list. We have to create the ages in a box plot and then find the IQR. We must list our numbers from least to greatest, so I'm going to do that. 9, and I'm crossing them out as I write them so I don't repeat any. And there's my list. Now we have to find the middle number, and we know there are 12 volunteers, which means it's an even number of data, so we're going to have 2 middle numbers. So let's see, 1, 2, 3, 4, 5, 6. All right, so the 6th and 7th number will be the middle 2. That's 15 and 21. So we're going to add those together and find the mean of those two to get our median, and that is going to equal 18. So our median is 18. Now we have to find our first quartile and third quartile. So we have this lower half of the data, and there's 1, 2, 3, 4, 5, 6 numbers. So we're going to have 2 middle numbers again because it's even. So that's 9 and 15. So we have to add them and divide by 2 so we can get the median of those, and we get 12. And do the same for the lower half. So these are our lower half of the data. And again, it's going to be 6. So the 1, 2, 3, 4, 5. I feel like I'm missing a number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I am. What number did I miss? So I realized there should be 4 21s, not 3. I forgot one. Okay. So thankfully that's in the lower half of my data, so that doesn't affect what we've already done, thankfully. But now we have to look at the median of that upper quartile. So we have 1, 2, 3, 4, 5, 6. So 3 and 4 will be 21 and 21. Those are our two middle numbers. Add those together and divide by 2. We get 21. So now we have our upper, lower quartile, and our median, and now our greatest number is 27. Our least is 9. So we need to now take the box plot and we got to move it to create our box plot. So our least number. Oh, I have to delete what I drew to move that. So our least number was 9. Our greatest was 27. Our median was, I gotta move this first. Our upper quartile was 21. Our median was 18. Our lower quartile was I forgot what our lower quartile was. 12. Our lower quartile was 12. Okay, so now we have our box plot. Now it says find the IQR. So that is the interquartile range. So to find the interquartile range, we're going to take our upper quartile number and our lower quartile number, so that's 21 and 12, and subtract them, and that equals 9. So again, IQR is subtracting the upper quartile number and the lower quartile number, and that difference is going to be your answer, which again is 9.